So Unit 3 is all about functions. So we're going to start with talking about if something is a function, and then talking about domain and range. So first we're going to talk about what a relation versus a function is. So a relation is just a set of ordered pairs. So it's kind of like what we have over there to the right. And then specifically, a function would be a type of relation in which each input is assigned to exactly one output. And inputs are our x values. So these would be our x's, like you would typically see in like an xy table. And our outputs are our y values. So a function means that each x has its own y. So for domain and range, the domain is always going to be the input or the x values, and the range will always be the y values. So domain is our x values. And when we list the domain, we just list out those values in order from least to greatest, and then we put them in brackets. So I'll show you that. So the range is our y values, and for both of these, we're going to do it from least to greatest. And we're going to put them in these kind of brackets. Another kind of weird, like those squiggle brackets. If you can't make it exactly, that's okay. But it can't be like these or anything, or that. It has to be somewhat looking like the squiggle brackets. So we're going to practice that up here with our first one. So let's start with the domain. And I'm just going to put D for domain, and then I'll put R for range. So starting with our domain, again, it's just the x values, so it's whatever is there on the left side. So I have 2, 4, and 3 right here, and I just need to write those in order from least to greatest. So my domain would be 2, 3, 4. Same thing for my range. I have 20, 30, and 40. These ones are already in order for me, so I'm just going to put those in the brackets. That's all you have to do for domain and range. So let's go on to our next example. We're going to do this XY chart right here. So I'll start with my domain. So again, it's these x values right here. Now I need to look for my smallest one first. So that's going to be -2. Then after that, it would be 0, then 2, and then 4. And then my range, just listing those y values. Now, if you notice, we have 2 -4s. If you ever have a repeat, you only write it once. So don't put -4 twice. Just put -4 and then go on to your next number. So that would be -1 and then 3. For graphs like this, sometimes it's easiest to write out all of the points that we have. Otherwise, you kind of have to go and you can see, like here I have an x value of -2, and then x value of 0, an x value of 2, but sometimes that can be hard to keep track of. So I would just go through and write each of the points and then list it out. So I'm going to start over here with this one. This is 4, 3. This one is 2, -4. This one is 0, -4. And this one over here would be -2, -1. So for my domain, I'm just going to list all of these x values here. I'll do this up here. So my domain, my smallest one was -2. Then I have 0, then 2, then 4. And then for my range, that is the y values. So I have a repeat here again. I have -4 twice, so I'm just going to put -4, then -1, and then 3. Okay, the next thing we're going to talk about is reasonable domains, which really just means a realistic domain. So it's just asking you, like, realistically, what values could X take? So my first example here says that Ryan is filling her swimming pool with a hose that fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So let's look at the amount of time. So we have 10 gallons per minute. So realistically, since we're dealing with time, we can't have negative values in our domain. We couldn't have like negative 10 minutes or something. So realistically, our domain value is going to have to be anything that's over 0. It's going to have to be a positive value. So because it has to be positive, we're going to write that x has to be greater than or equal to 0. Now it could be 0, and that would be like at the beginning if we weren't filling anything up at all, but we can't go into the negatives. And that's for the domain. Sometimes they might ask you about the range too. And so we could look at our range, and our range is going to be that 10,000 gallon swimming pool. It's going to be how much water we're putting in. So if they were to ask us about the range, well, we know that the swimming pool only holds 10,000 gallons. So realistically, the range has to be somewhere between 0 and 10,000. So if they ask you about the range, we would just say that that's our y values. My y value has to be less than or equal to 10,000. But again, it also can't be negative because I can't have negative amount of gallons in the swimming pool. So I'm going to say that it also has to be greater than 0. And that's how we would write that. So that's just kind of saying it's in between two different values. And if you're ever trying to write anything in between two values, it's always going to look like that. You'll always have your smallest number and then your symbol and then either X or Y, and then your less than symbol again, and then your biggest number. So if you're ever trying to go from like in between two different numbers, like from 0 to 10,000, that's how you'll write it. So the next one says that Chaz needs to order chairs for a restaurant he owns. One table must have 4 chairs. So we're talking about tables and chairs here. So I'm going to put tables. We'll talk about those first, and then we'll talk about the chairs. So our tables, it doesn't tell us anything about a limit of tables. So we're just going to assume there's like unlimited space since we don't know how much. But again, we can't have negative tables. So just like above, I'm going to say that my x values have to be bigger than or equal to 0. I could have no chairs or no tables, but it's got to be a positive number. So for my domain, it's going to be bigger than 0. Now my chairs technically also have to be that, but each table has to have 4 chairs. So that means that my y values have to be in increments of 4. So if I had no tables, I obviously wouldn't have any chairs, but then I would have 4 chairs. And then if I had 2 tables, I would have 8 chairs. If I had 3 tables, I would have 12 chairs, and so on. So I'm just going to go in increments of 4 and show that it's just going to keep going like that for my range. And then next it says that Stella keeps track of her work hours per week in an Excel sheet. So we're just looking at work hours per week here. We only have one thing we're looking at. So we're only going to have just a reasonable domain here. We're not going to have a range because they don't give us anything else. So if we're looking at the number of hours a person works per week, on average, it's about 40 hours. So I want to say in between 0 and 40. And so if you remember, like what I did over here, if we want to say from 0 to 40, I'll put my smallest number, so 0, and then I put my symbol, and then I'll put X, and then I put that symbol again, and I put my biggest number, and that's going to be 40 hours. The next thing we're going to look about is continuous versus discrete domain. So there's some pictures over here to go with it. My first one is the example of continuous, and the other one is the example of discrete. So for something that is continuous, it means that it goes on and includes all numbers, like in between something. So it's going to include all decimals and fractions, all real numbers. So if we kind of zoom in here, oh, or not, where'd it go? It's kind of blurry now. Okay, well, there we go. If we're zooming in here, you can see that we could go over to 1.1 and have a value. We could go over to 1.2, have a value, 1.3, and so on. I could go to 4.5 and have a value. There's a value at every single point in between this dot and that dot. So continuous domain has all real numbers, which includes, decimals and fractions. And then discrete is kind of the opposite. There's only going to be specific data points that it's going to fall on. So if we're looking at the other graph over here, it's only these dots that are on the graph. There's nothing in between. There's no line going through them. There's not a point at 2.1 and 2.2. There's only going to be a point right here at 2, 4. So it has to be specific data points. And then we kind of bring in word problems with this. Not really word problems, but just like an explanation. So if we have a bowler that's playing or paying $3 per game, would that be discrete or continuous? Well, if they're only paying $3 for each game, it's never going to be like $3.50 for a game. It's only going to go 3 and then 6 and then 9. It's only going up by $3 every time. And so we're only going to have those specific amounts. We'll never get like a cost of like $12.50 or something. So this is going to be our discrete one. Whereas our other one, a car traveling 25 miles using 1 gallon of gas, is going to be our continuous one. Because you could go 23.2 miles and use less than a gallon of gas. There's all these different data points in between as they're going those 25 miles. After 1 mile, you've used a certain amount of gas. After 1.1 miles, you've used a certain amount. So there's a whole lot of data points. Okay, this next thing we have here is about types of functions. So functions can be one-to-one, many-to-one, and then one-to-many would not be a function. So if we look over here at our first two pictures, we have a one-to-one function and a many-to-one function. So remember, functions have to have an input for each output, x to y. So if we're looking here at our first example, each of my inputs has exactly one output. There's no repeats anywhere. Now if you look at a many-to-one function, each line is only going over to one thing, but there is some repeats here. So I have some y values that repeat over here. So if I were to like write these as points, I would have 1, 2, and then 2 goes to 6, 3 goes to 6, and 4 goes to 6, and then 5 goes to 1. So I do have some y values repeating. So if my y values repeat, it's a many to 1. However, if my x values repeat, then it's called a relationship and it's no longer a function. So if I look over here, if I were to like, again, write these out kind of like points, this would be 1 to 2, 1 to 3. And then 3 just goes to 4. And then I have 5 to 5 and also 5 to 6. So if I have x values repeating, it's no longer a function. So that's the most important thing to remember, is that if your x values repeat, then it is not a function. So only the y values are allowed to repeat. Okay, now we're going to look at, let's see, 3 more examples of that here. So we'll look at our little xy chart here first. So it just wants to know, is it a function? And then it wants us to label it. Is it a one-to-one? Is it a many-to-one? Or is it one-to-many, which means it's not a function? So looking at this first one here, I have -2 to 5, but my 3 goes to 6 and to 7. So like looking at that as points, I would have -2, 5, 3, 6, 3, 7, 4, 8. My x values over here are repeating, so it's not a function. My x values cannot repeat. Okay, looking at our next one, because this is a line, I know that on a line, there are just points all along it. And it's never going to repeat anywhere. It's just going to keep going on in this direction and keep going on in this direction. So therefore, it is a function, and it's going to be one-to-one because each x value that I go over is going to have its own y value, and there's no other lines on here, so it can't repeat. So this is a one-to-one function. And then our last one is just a set of points here. So I'm going to look at my x values. I have 1, 5, 7, and 8. My x values don't repeat. My y values are 2, 6, -1, and 0. Those also don't repeat, which means it is again a one-to-one function. So our last one is talking about constraints on domain. That's kind of like what we did, let's see, right here, realistic domains. It's also kind of talking in a similar way to that. So it says that Margaret has monthly close budget of $50. She's mapping her spending. What constraints on there on the domain? So this is again saying, like, if we're looking at our domain, what values is it allowed to take? So if she has a budget of $50, that means that the values that x can take can only be between 0 and 50. So she can only spend between 0 to $50. So if you remember again up here, how I showed you to write, if you're writing like in between two numbers, so I'm going to have 0 to 50. So 0 less than or equal to x less than or equal to 50. And that's my constraint on the domain because I can only spend in between those two amounts.